I'm the president of the moon, but don't tell my cats, they think they're in charge. I'm the mathematician, but that doesn't stop me from having a good time. If only I could find my keys. I'm the artist, but life isn't just about lines and color. My favorite shape is knowledge. Hey Prez, what's happening? Can't wait for our trip to the moon. Hey Matthew, I loved your application, but there's just one more thing. The flag. OMG, artist, I need you! Hey Matthew, how's the ball? Any drama? Yes! Where are you, by the way? Oh my god, we're having so much fun. We're in the Bermuda Triangle for our people's trip shoot. So much drama. The president wants to know the area of the pink shape in our flag before we can go to the moon to complete our application. She said something about FTC, like from calculus 20 years ago, but did we even cover that? Oh, the Fundamental Theorem of Calculus? Yeah, we totally covered that. The Fundamental Theorem of Calculus, Part 1. If f is continuous over ab, and capital F of x is the integral from a to x of lowercase f of t dt, big F is the area under the curve function of f, little f, then f prime of x equals f of x over ab. Oh yeah, I even remember the proof. F prime of x, by the definition of derivative, equals the limit as h goes to 0 of f of x plus h minus f of x over h, which equals the limit as h goes to 0, by the definition of f of x, capital F of x, is the integral from a to x plus h f of t dt minus the integral from a to x of f of t dt over h. Which, if we just switch the bounds of integration on the second integral, we get the integral from a to x plus h f of t dt plus the integral from x to a of f of t dt over h, taking the limit as h goes to 0. But combining those integrals gives us the limit as h goes to 0 of 1 over h times the integral from x to x plus h of f of t dt. But that's just the average value of f over the interval x to x plus h. Thus, by the intermediate value theorem, there exists a c in x to x plus h such that f of c equals the average value on the interval x to x plus h. That is, f of c equals 1 over h times the integral from x to x plus h f of t dt. But notice, as h goes to 0, c goes to x, since c is in this closed interval. And since f is continuous, the limit as c goes to x of f of c is f of x. Then f prime of x equals the limit as h goes to 0 of f of c, which is f of x, which we wanted to prove. Oh yeah, I can't remember that, but that's not the one she was talking about. It was something different. Oh, right. You're probably talking about the Fundamental Theorem of Calculus Part 2. The Fundamental Theorem of Calculus Part 2. If f is continuous over ab and f of x, capital F of x, is any antiderivative of lowercase f of x, then the integral from a to b of f of x dx is f of b minus f of a. Oh yeah, I remember the proof of this one too. Let P be a regular partition of AB. Then f of b minus f of a can be written as f of x n minus f of x 0. Then f of x sub n minus f of x sub 0 is, keep breaking it up, is f of x n minus f of x sub n minus 1 plus f of x sub n minus 1 minus f of x sub n minus 2 plus f of x sub n minus 2 minus f of x sub n minus 3 and so on to get to f of x1 minus f of x0. Which equals, by the sigma notation, the sum from I equals 1 to n of f of x sub I minus f of x sub I minus 1. By the mean value theorem, for each I, we can find a ci in x sub I minus 1 to xi such that f of xi minus f of x sub I minus 1 equals f prime of ci times xi minus x sub I minus 1, which equals lowercase f of ci times delta x. Putting it all together, we have f of b minus f of a equals the sum from I equals 1 to n of f of ci times delta x. Take the limit as n goes to infinity. Then f of b minus f of a equals the limit as n goes to infinity of the sum I equals 1 to n of lowercase f of ci delta x, which is the definite integral from a to b of f of x dx, which is what we wanted to show. Oh yeah, that's it. You got it. So, what's the area of the pink shape in our flag? Oh yeah, what function did you use to draw that? Oh yeah, I did. I think I did e to the x from 0 to 1. Okay, so the area of the pink shape is the integral from 0 to 1 e to the x dx. But e to the x is its own antiderivative. So we evaluate e to the x from 0 to 1. So first plug in the 1, so e to the first minus e to the 0, which is e minus 1. We did it. Welcome everyone to this party on the moon. Thanks so much to the mathematician and artist for this amazing flag.